Hello, and welcome to the Elation Innovation Hour. And Happy New Year to all of you. Today we're coming to you from snowy and cold Minneapolis to talk about the innovative and unique color mixing systems in the Elation product portfolio. And I have to say I'm very gracious to the team here at Legacy Productions who's hosting us today here at their studio, and they support us with their AV gear and some personnel, so really thanks for that. Of course, I brought a lot of fixtures with me as we have so many different color mixing systems here at Elation. And to help me with today's webinar, I also virtually brought my friend Dunn along, who is part of our Elation US sales team. Hey John, Happy New Year. It's like the first time we're back at this Elation webinar series.
Hey Matthias, thanks for bringing me along to support you on these innovation hours. These are always fun for me, whereas the Elation hours, you are kind of here to back me up, and in these cases, I'm here to back you up, and I really enjoy this side of the coin. Happy New Year to you as well. Thankfully for me, I'm in sunny Southern California while you're kind of freezing in the tundra up there.
It's actually pretty nice today, but tonight we're going to go to wind chill of like -10 or so. We'll maybe frozen to the ground by the time we get out.
That's less than ideal. I might try to swing in some clubs later today.
Nice. Yeah, not me. All right. Want to give a quick recap of the events we did over the last year and what we kind of have in store for 2021?
Would love to. Well, thank you to everybody for joining us. 2020 was a challenging year, I think, for everyone, but there are some positive things that kind of came out of that, and one of those was this Elation Elation Innovation Hour, and we have a third entity coming out with the Elation Project Hour, which will be hosted by our own Bob Mentley, where we'll dive into kind of project-specific things and get deep dives in why decisions are made and give you guys some idea on some of these really large-scale projects, one of which would be the Metropolitan Opera. Another one that we'll be touching base on later this year would be the San Diego Symphony and their new outdoor shell performance venue, which unfortunately was delayed. And then on top of that, we're going to have more innovation hours with Matthias, including this one with color mixing systems, and we'll be doing new product launches and comparisons for you. And then we'll also be doing the Elation hours where we'll talk to designers and industry experts about state of the industry, vertical markets and applications and how best to use. And as we go hopefully back into live events as a group and as a community, we can kind of leverage all of that brain trust together and really make some fantastic events. Regardless of your political leanings, I think watching the celebration of America last night on TV really drove home for me how much I miss live events. And I think the entire country feels the same way. So for 2021, I'm hoping that we can, get a little bit back more to normalcy and enjoy some live events as a group and as a community and as an industry.
Great. Thanks, John. I also should point out that all the Elation Hours, Innovation Hour from last year actually hosted on our website at elationlighting.com. So you can review any of these if you missed them. This one will be uploaded in a few days as well. And as always in these, you're very welcome to ask questions. John is going to monitor the Zoom question and answer session. So if you use that, put some questions in there. He'll chime in between, either while I talk about a specific product. At the end, we have a small Q&A session as well. So keep an eye on that, and John's going to help me through this. But let's get started and look at some lights. I set up a variety of fixtures today that are a good representation of the color mixing systems we utilize in the Elation fixture range. All of these are LED luminaires, but have some fundamental differences how color is generated and controlled. I think it's going to be really interesting to take a closer look at them, see the color mixing results for yourself, and discuss a bit of the pros and cons of the different technologies. So on the left, the first fixture we're going to talk about will be the KL panel. We have the DTW blinder next to that, which is a white amber color engine. Then we come to the fuse pendant, which is a downlight product. We have 5 LED colors in here: red, green, blue, white, and lime. Next to that, a bit an older fixture in the portfolio, the Fuse Wash Z120. This is actually an RGB white LED. Then we're going to talk about the Fuse SFX, which is a product we recently launched. Here we have a white LED engine, and we use color mixing through wheels of cyan, magenta, and yellow, and there's a little twist to it as well that we're going to showcase here. And then next we have the Fuse profile. Here we have a 5-color high CRI blended engine, and that features red, green, blue, magenta, mint, and amber. And then last, at the end here, we have the Artiste Monet. We also, the webinar today is lit up with all Monets here in our studio. So the key light on me, the light on all the fixtures, that's all Artiste Monets. And here we have also a white LED engine again, and we utilize our very unique and sort of groundbreaking, really, spectra color system. And we have a small video actually that also will explain this a little bit more. And of course, everything is controlled by our own NX2 running the Onyx software here. So let's have a look at the first one, which will be the DTW. So the DTW blinder is an IP65 fixture that exists in a 2-cell and a 4-cell version. It features warm white and amber LEDs. And this is done to really replicate the tungsten and the warmness, like the warmness of the tungsten bulbs that you normally find in these, emulate the dimming curves when you have this on a traditional dimmer. You know, there's a certain feel to blindness that we really want to replicate in this. And this one is actually features a revised firmware that we're going to launch within a week or so, that are worked on, where we did some further improvements on the dim to warm function. So what you saw here was only the white LEDs. Then the fixture also features a set of amber LEDs, and these help us on this color shift, actually. You are able to blend these in any way you like. So if you only want the warm white LED, that's which one? That's the one here. You can do your own color mix of warm, so it's warm white and an amber LED. But let's see how this looks together when it's mixed. So here you have a fixture. I'm running it a bit lower than full because with the camera, I want to make sure that it doesn't blow it out. I'm going to dim this down now with the dim to warm function. And you see that it gradually fades out. It gets redder and redder and redder until it fades out. It's very smooth. This is actually modeled after a 1K tungsten Fresnel fixture where we measured all the different intensity and color shifts and then built that curve into this fixture. This would be a fade without the dim to white on. So in this case, you do not have that color shift. So dim to warm. Dim to warm will modulate the amber and white LEDs together to get you this like nice red shift at the end. If you turn that off, both colors will together fade down, and then you do not have that integrated red shift. You can also see this difference here. If I add another effect to that, So here the effect is actually white on and off. So there's no redshift happening as this effect pulses around. So now I'm switching the dim to warm on this effect, and you see now I'm running a little effects like a sine wave over it from the console. And as the fixture dims down, it gets warmer and has this like lag in there that's similar to using them through a traditional dimmer pack.
It's amazing how much time we spend, Matthias, in
Not hearing him.
emulate old technology.
Sorry, say again, John? You were muted here in the room, sorry.
Oh, sorry. I said it's amazing how much time we've spent, and obviously we're now revising the software to make new technology emulate traditional technology.
That's true. I think there's just a certain organic feel to that. If you write a fader, you want the fixture to have a bit of that lag. You want it to be warm as you dim down. Because it's a bit like listening to vinyl, I guess, is a good way to compare this. It has a certain warmth to it, and it's not accurate. A CD or an audio file will be way more precise, but it may feel unnatural to you. So I think that's the same. I've seen the renaissance of like vinyl sells more than CDs now, and that's probably a pretty good comparison. So yeah, pretty straightforward. You have two colors in this mixing system: warm white and amber. You have some automation in the DTW products to automate this dim to warm, to utilize a tungsten curve, and basically trying to emulate an existing blinder fixture as natural as possible. All right, I'll fade this out.
Quick question, Matthias. Is there any additional products that you, besides the DTW blinders, I think that's the only one that uses this color system currently. Do we have a plan for future products?
So right now it's a DTW, the 350 and 700 that contain that.
Mm-hmm.
Actually, it's some of these fixtures we have, we would be able to do now that we've redone the algorithm on this DTW. I think we're going to do some more work. This is actually a fixture that's quite a few years in the portfolio, and we continuously evolve these and develop these. So I can see us also adding that to some other products. For instance, like when we talk about diffuse pendant, I think that may be a mode that we may want to add to that, because as you dim your house light down, you may like this warm shift, because it also feels more natural. It may blend in better with products that are already in your venue, for example. Yeah.
So anything with an amber chip could be added this DTW curve and algorithm to it. Amazing.
Also the fixtures that have these like full spectrum engines that we're going to look at later. There we have the full color range to actually do something like this.
Amazing. I like that.
Yeah.
Thank you.
Sure. So the next product we're going to look at is the KL panel. So the KL panel is a fairly new product that we introduced last year. This is a soft light. Applications are primarily television, movie, psychs, but also there's stage applications, corporate AV, just like a generic fill light, a front wash. There's many applications for this. This is a 300-watt engine, has a very high color rendering and index and TM30 values, so the color quality is very accurate. Let's see the different colors we utilize in here. In this case, it's actually a 6-color engine. And the colors we have here are red, which you see here. We have a green. So that's a primary green. Then we have a primary blue. And because the product is, the majority of time a product like this is used will be a dynamic white environment, so you want to recall specific color temperatures. We have additional colors in here to help with this in the full spectrum. So you have white, lime, and cyan. And actually, You may think, wow, that's kind of an interesting choice of color to mix white together, but actually the way, especially lime, really helps to sort of fill in the whole spectrum, and it's a very efficient LED as well. So in this case, you end up with a very, you don't have a lot of peaks. It helps sort of smoothen that out. If you look at a white LED, often they like have a very high peak in the blue spectrum. On a product like this, where you have 6 different colors, you can blend these together. We also don't run every color just at full. Like there is algorithms and some intelligence in there, and the fixtures are all also calibrated. That's another thing where these multicolor engines are really helpful. You can calibrate these over computer systems that adjust all these colors to make sure that every product that leaves the factory is exactly the same. I'll fade this out. And as I said, the majority of times, these products will be used to actually call up this very specific color temperature. So this would be 2400 K or Kelvin. And this fixture has a very wide range. It goes all the way up to 10,000 actually. So I'm going to slowly fade through this, and I'll get bluer and bluer. So it's going to go through like a pure white, and then it almost goes, it's like a bluish white at the end at 10,000 Kelvin.
Just like a steel blue.
Yeah, it gets really, but yeah, correct. That's a good way probably to describe it. So jump back to a more common temperature. So that'd be 4,500 K, which is I think close to what we calibrated in here. My colleague here, since it's a color mixing webinar, he's constantly chasing on his camera unit there, because it's obviously quite difficult to replicate these fixtures accurately so they look correct to you on the webinar. Another adjustment this blended engine allows us is a green shift. So we can adjust the fixture to a full minus green and a full plus. So that'd be a minus green, so the fixture actually turns pretty much into like a pinkish magenta shift. And then it fades through neutral, and that is actually a DMX channel. So you can remotely adjust this while you look at the fixture. This product in the back actually has a bunch of encoders as well, so you can operate the KL panel without any DMX control at all. All these, the recall of intensity, the CCT temperature, the green shift, all that is available through 3 different encoders on the back. On these multicolor engines, we also add a virtual color wheel. So you do not have to worry about mixing 4, 5, 6 different colors together. We actually include a variety of like common colors. I'm just going to run through these here. I did this manually. So these are all pre-mixed colors that you can recall. They're created along the Lee catalog, so you're going to find like Palos blue and magentas and marine blue and those kind of colors right in here. There's a table that is part of the user manual, and that allows you to quickly recall it. If I pull this up on my console, I want to pull up scarlet red, loving amber, gold tint, yellow, dark magenta. So it's like very easy to recall these. Yeah, so that's a big advantage of these multicolor engines. You have a very nice spectrum. You have a lot of very precise color temperature control. You have the green shift control. You have virtual recall of pre-mixed colors. You can operate the products in different control systems. So here I'm using it in a 6-color mode. We offer a CMY emulation. We offer HSI, so hue, saturation, intensity. to make the recall of colors a bit easier, because it can be sometimes daunting to operate 6 different parameters for this. Yeah, John, any questions come up on this one?
We do. We have a couple of questions. One of which is, how does this 6-color selection impact the CRI? So where's the biggest CRI impact coming from? What color range in this fixture?
That's actually a good question. I don't know 100% the answer to that, to be honest. I would say it's primarily the lime that helps us increase the CRI. That's also, interestingly enough, that lime is the strongest color in it, in terms of like output. It actually contributes the most to the intensity of the fixture. There's really not necessarily one specific color that helps here. It's like really picking the right colors and to get that blend right and get the algorithms right, how these 6 colors interact with each other. So it's not necessarily you can take one away. In this case, we went with a 6-color system to get the brightness really high out of this and widen the color range, so you cannot go up to 10,000 K. On the other products, which have only a 5-color engine, you're a bit more limited. You cannot go quite as high, for example, in the color range. So the cyan, for instance, helps us on the high color temperature on this.
So it's sort of like cooking. It's a secret sauce.
It is a bit. There's a lot of secret sauce in all of these products from every manufacturer, for sure.
Before I get to a question that not related to color mixing on the product, there is one related to the HSI.
Okay.
And the HSI obviously, does that engage all 6 colors?
Yes. Yeah, when we do these emulations and reduce it to, let's say we have a 5-color engine, we reduce it to CMY, it uses all colors. Yeah, and it basically it mixes these colors for you. So if you have a CMY and you turn all the colors off, it'll be white and all 6 colors will be on. If you go to HSI, it'll use all 6 colors. So if you go to an HSI that creates a white, all colors will be used. As you move around in the color space, the fixtures algorithms will pick the right amount of brightness for each color to recreate this, the color that you like. But yes, always all the colors are used.
Great. And then there was a question about, it's a 300-watt engine. Is there any breakdown of wattage per color?
That's part of the secret sauce.
Great.
Yeah. Because it's
proprietary information.
It's sort of.
Thank you, Sergio.
I don't think it's really that helpful to know. We do provide, however, very precise photometrics. So you can look at the intensity that you get out of it, which is way more important than the wattage of how many watts of red or green are in there. That doesn't really tell you anything, because it has also to do with how we drive it, how the cooling of the product is. But our photometrics will actually show you the intensities and the exact color that is used for red, green, and blue. And that is all on our website. I think the report for the KL is over 50 pages of color detail. So we're not trying to hide anything, but wattage is not necessarily the best way to gauge how well the product will perform in a specific color. So I would really recommend to look at the photometrics reports of these.
Excellent answer, my friend.
Yes.
2 more questions for you real quick.
Sure.
Let me get to the one that's not related to color, and then I'll jump back to Mr. Ravitz, who just chimed in about something. But we see that there's a frost filter on the front of the unit. And for those who are familiar with the product, we do have a soft bag accessory for the product
as well. Yeah.
Than a snap grid.
Yep.
Is there any other frost filter options like the hard frost that is removable on the front, or is that recommended and add additional pieces as you would normally do?
You can remove the frost that's in there. That's actually you could insert a different one if you'd like. This frost is chosen it helps with the blend of the fixtures as well. So if you get really close to the product, which may happen on a certain camera shoot, you may use it in a photo lab. You do not need that much distance. If you take the frost out, the colors are, it's a bit stronger, but the colors take more feet to sort of pre-mix and pre-blend. We are looking at a couple of other options as well to offer different frost variants to that. But at the moment, only the one that's in the fixture ships with it. The barn door that you see on it ships with it. And you can remove it or add it as you like. I think the fixture is really designed to use the frost like this, so that's sort of the optimal performance for it at this time.
Great, thanks for that question, Matt. And now we have a question related to using the Lee color virtual color swatches that you mentioned. Once you're in a preset color, are you able to then take individual colors and adjust or tweak that preset color?
No, you're not. So the way the firmware is designed, once we recall a color, the other colors are disabled.
Okay.
So you only can recall a color as it is, and you have no way to adjust them besides the intensity.
And you lose the magenta and green shift as well?
I don't know. Actually, I haven't tried this. I think you do. We can try. Yeah, the way those virtual colors are designed is it's an absolute, it recalls that specific.
It locks everything else out.
Yeah, everything else is locked out. So you lose control of color temperature, all the 6 colors, and the green shift.
Great. Jeff, I may revisit you on that and discuss a firmware update potentially with Matthias and yourself.
All right.
So thanks for that question.
All right.
And that kind of sums that up.
Good. Well, let's look at the next one. To the right of that, we have the fuse pendant. So fuse pendant is primarily used as a house light fixture. So it's a traditional sort of pendant that you would hang. Very big application. It's a house of worship market, by any auditorium, arena, theater, auditoriums. I think they're all great applications for this. One advantage here is that you have, this is a fanless fixture. It's convection cooled. It features a 230 watt RGB, so red, green, blue, white, lime LED engine. So slightly different color mix chosen here, also again based on the application, primarily going to be used in white, dynamic white applications with the option to go to specific colors. But I would say, probably 90% of the time that fixture will be running in a certain color temperature and a certain intensity. So it's an adjustable white. You have a very high CRI with this. Again, you want colors, people, the room that you're in to look accurate. So that's very important on these. You have a virtual color temperature again. You have virtual colors so you can recall. So let's have a look through this. So you have red. Then you have a primary green, a primary blue, a dedicated white chip, and lime. And these colors were chosen basically, as I said, to really get a very high output in white tones. So really the focus on the fixture has been to provide a very good white and a lot of output out of those 230 watts. You have color mixing.
Matthias, do you know what the color temperature is of the white?
Of the actual white? Not at the top of my head, but again, it's in the photometrics report. Similar. We have every color is measured individually, so you can really see how the different colors perform, and you can see the different color temperatures or the dominant wavelength of the different colors in the photometrics report. And the report also has beam spreads and intensities for some reference color temperatures like 3000, 4500, 6000 K, and so on. So the color range of this fixture is a bit smaller than the KL because we do not have the additional chips to sort of push it really into the high color temperature, and that's not really needed for this application. So we're better off in a product like this to focus the energy to create whites that are commonly used for that light. Because if you end up driving, you have LEDs in there you may never use. It's really unusual that you would run a house light application at 10,000 K. So in this case, the fixture runs from 2,400 Kelvin to 8,500 Kelvin. Again, as the KL panel, it contains virtual colors. So you're able to recall a range of colors right over the DMX channel. There's a table in the user manual. In this case, the fixture also allows you to, it can actually be run only on one DMX channel. And you can preset the color that you like for the product. You may have a retrofit application. You may not want to invest into a more complicated or a larger control system. In this case, you can set the color temperature on the back of the fixture and run it over a single DMX channel, because that may be all you have based on you had a dimmer pack before, and you may have only a house light control that can only dim up and down. So in this case, you set the color temperature you want, 3,200, 4,000 Kelvin, whatever is appropriate for your venue, and then you'll have a single DMX channel. This fixture also has a 0 to 10 volt control, so it can actually also be driven through analog control if that's something you have. Sometimes you have existing architectural fixtures you may replace that have a 0 to 10 volt ballast control that will be accessible as well. So pretty straightforward fixture. It has replaceable lenses in the front. In this case, there's a whole range. Depending on the height you install the fixture at, they're easily replaceable in the field, even after the fixture is mounted. The fixture can be hung, of course, from the ceiling with a specific bracket or with a pendant. You can there's an accessory to mount the fixture on the wall. There's like a yoke you can get, and there's also an in-ceiling adapter. So the fixture can be placed with a trim ring, or it can be supported actually on ceiling joists as well. Has a really good color range, and it's quite fun to, I hope that more and more people will start utilizing products like that, even in existing auditoriums. And I think it's really nice to be able to crossfade through a specific color on a blackout in a theater, for example. Or maybe there may be parts of shows where performers are in the audience that gives you the ability to interact with lighting out there, and you have a fully dynamic white and color mixing house light system that you can utilize. Yeah, any questions came up on that, John?
No, actually.
No. All right. Yeah, I mean, it's a simple fixture. Does what it does really well. Again, 230 watts, RGB, white, and lime in this one.
For those of you guys who are not noticing a trend, we are sort of really going with a full spectrum, full color LED chip versus dynamic white chips to get these variations of white with very specific colors fixated to do that.
Yeah, that's a good point. There's also a very good reason for that. If you do a dynamic white, so you have a whole package of warm white and a whole package of cold white, in that warm white color, you're only going to engage half of the LEDs that you built into the product. So you may pay for something you actually rarely use it, and you lose output in that case. If you run primarily in a higher color temperature, you may only use 10% of that warm white package, and the fixture would only be at its best performance when both colors are on together. On a fully blended engine like this, all the colors are mostly on all of the time in a certain kind of mix, and they're very efficient across all the different, like if you look at the color temperature control on the pendant or on the KL panel or on the fuse that we're going to look at in a second. It's much more efficient to do a full color, full spectrum engine like this. Yeah, good point. I think we're going to see less and less of these dynamic white products only that can only do white. And obviously you have such a much broader range. Another advantage is that the products can be calibrated much better because you have 5, 6 colors available. You can tune this really precisely and make sure that all the products that we deliver to you are perfectly the same.
Fantastic.
All right, let's look at the next one. Fuse wash 120. I brought this along as an example of a simple RGBW fixture. So let's page over here. So this is a compact small watch light. It uses what's called a COB, C-O-B, chip on board LED engine. So rather than little LEDs with individual optics, here you have a larger disc where different areas of that LED engine are illuminated, and that's how the color is created here. Then there's a reflector, and you have a front lens. In this case, it's also zoomable as well. It's a bit simpler optics, but it's quite efficient and also cost efficient to do color mixing products this way. Nice about the fuse watch, we have the 120 and the 350, is that it's a homogenized and blended engine. So you have no individual dots and no individual small lenses. We have a product like that. That is the Razor 760. Not different kind of product. A lot of it is to utilize the different LEDs for effects. Here, it's a more traditional wash light. It looks like Fresnel or Par that you have a color attached to. So you don't see individual colors in the lens. So it looks very clean. And we really like these. We have a lot of these blended wash lights in the portfolio now. So the engine here you have is red, green, blue, so this one, and you have a white. The spectrum here is a bit more limited. On an RGB white engine, you tend to be a bit stronger on the blue end. That tend to be, if you turn all colors on, you probably ain't gonna end up a little purple. But because there's only 4 colors, you actually have more intensity on the individual colors. So on red, green, and blue tend to have a bit more punch on their own. It's probably an advantage of these kind of products. If you want to use this to create a specific color temperature, use it as a key light to illuminate somebody or to illuminate objects. Often you have to dial in certain colors quite a bit to achieve that. Especially blue tends to be, as I said, quite strong. But the fixture does a really, really nice job in mixing colors together, like magenta, cyan. So you have an RGB engine, obviously through combining the different colors, you can create CMY, pinks and blues and so on. So it's pretty straightforward light. An example of color mixing technology as it was pretty dominant over the last decade really, where LEDs really the first ones were RGB, then it was RGBW. Now you see some products with RGB amber, so they perform a bit better on the maybe warmer spectrum. A lot of them are RGB white, especially the ones with individual LEDs. The majority of those are RGB white fixtures. One advantage also of these engines and that optics is that you do not have any color fringing on it because all the color exits out of one large lens. So you do not have differences. The shadows will be natural, and you have no color fringing, and it gives you a very smooth field. So it's like for a watch fixture, that's actually a really efficient way to do something like this. And these engines have evolved, as we're going to see in a bit in the fuse profile. So there we're going to see how you have a 5-color engine, and you can do all this additive color mixing in a really amazing way. Was there any questions on this so far, John? Just double checking.
Nope. Just to remind you guys, this is the Fuse Wash Z120.
Yes.
I guess I have a question.
Yep.
Do you see the benefit of RGBW staying for some period of time based around that intensity difference that you just mentioned?
I think for fixtures like the Razor 760, the Razor 360, some of the simpler power fixtures, like 6 power series from us, RGBW makes a lot of sense there still. A lot of times these products are used in primary color. You want very strong reds, you want really high intensity on these colors. And the RGBW mix is sufficient for those kind of products. So I do not think that they're all going to go away. I think they're going to stay relevant for quite a while.
Right.
It really it depends on the application. We have the 7 power series where we have a blend that even includes something like UV to help you with certain colors, or to just run the UV on its own. So it kind of depends to really pick the right product, I guess, for the right application. And all that, there's cost to that. As you use more complex LED engines, the cost benefit may not always work out. And so a product like the Fuse Wash 120, this was a really good choice to use RGBW for this. Yeah, did that answer your question?
Very much so.
All right, so next one. That's one of my little favorite lights. It's the Fuse S effects, and that actually stands for spot effects. It's quite an interesting fixture. Here you have one single unit, 300 watt white LED that has a very good zoom range to go from very narrow to a reasonably large field. It actually can emulate a beam fixture out of this as well. It has a very good frost to replicate a wash light. So it's like pretty much an LED hybrid, I guess you could call it. We chose SFX because it has a couple of little tricks in there as well. So here, 300 watt engine, native color temperature of 6,600 Kelvin. And this fixture is the first one in today's demo that actually uses a mechanical color mixing system. So in this case, it uses a disc. So most color mixing systems are curtain-based, and there's a video coming up in a few minutes that will showcase that. Here, it's actually a wheel. That's a technology that's been used in the past quite often on fixtures. So you have a CMY mixing system with discs. And that actually allows us a couple of fun tricks. So you have the traditional cyan, magenta, and yellow mix. And of course, you can overlap that, which then gets you through these warm ambers into a red, a primary green. So one thing that happens here, since it's the first time we have a color mixing system that's mechanical, so here you have 1 or 2 or maybe even 3 discs coming in that are saturated with a gradient of color. So the more you insert the disc, the stronger the color gets. Which also means this is a subtractive color mixing system. So you have all the white energy of the LED, you pass this through this filter, and only what's left in the spectrum will actually is the resulting color you get. If you put 2 on top of each other, your transmission starts to get lower and lower. So on a CMY system like this, a red may not be as punchy as it is on an additive mixing system. So because there, red is the only color that you drive, it's more efficient to do that way. So there's some pros and cons to that. But a fixture like the SFX, in white, the performance is very, very high. Where sometimes the performance of an additive mixing may, if it's the same wattage, like the Fuse profile next to it is also close to 300 watt. The Fuse SFX may be a little bit brighter in white. So it depends on the application that you utilize the fixture for. So if you go through, especially blues and reds on the CMY system, you're going to see that the output is not as strong as it would be on an additive system. So what's interesting on this fixture is that we have an overdrive on like a color effects option in here, and that actually allows us to drive the wheel past this most saturated point. And better to see it in person. So what it does here actually is the wheel shoots past of where it's full cyan. Then you can go into split colors. So you can see here, I'm going to go back to open. I can scroll the color through. So the fixture has like, it increases the color, snaps to white, increases the color, snaps to white. Here's an example of a Dunn that split with magenta. Here you can see this is a mixture of a wheel. This is actually two wheels, so magenta is coming in from one side and cyan is coming in from the other side. That's how you get a half color like this. You can also even combine it with a fixed color. In this case, you could create a triple color split in this fixture. So that's kind of where the SFX idea comes from. So you have a center color, which is a yellow chip on a actual color wheel. Then you add magenta. That'll get you the red on the top. And you add cyan. That creates the primary green on the bottom. So that may not be that interesting when you project it on the screen, but it's a good way to understand it and see it. But if you use it as an effects fixture in the air with some prisms and gobos, it is, there's a lot of interesting things you can do. And the fixture actually has some pre-made color splits like this built in. So they're easy to recall. You don't have to worry about dialing this all in manually. If you don't want to, you just push a button and you get a split like this. There's like a white, magenta, cyan. And you can quickly see which one you like. So it's a quick way to get some really fun color things out of this fixture. In addition to the CMY wheels, it also has an actual color wheel. So it's a disc with individual colors glued on it. In this case, here's some half colors you can do. And then that half color, the other half, you could use a wheel, for example. Just going to scroll through this real quick. The wheel also contains a CTO, so in this case, you do not have control which color temperature you want to go to. There's only one CTO color in there. In this case, it's CTO because you're taking a white color and you're changing it to a color temperature orange. On the other fixtures, it would be CCT, correlated color temperature, because you have complete control of what color temperature you want to go to. In this case, on a fixture like this, it is only on it's a chip on this, because it's probably not the fixture you're going to use often for like a key lighting application. The primary use will be on the stage as an effects fixture. However, it does include a CTO. It does include a high CRI filter in case you do, on occasion, want to light up somebody with it. And you can just see the difference between that here. So you can actually not, in real life, you see this a lot better. If I would have somebody standing in there, you would actually see this. So that is really just depending on the application. So yes, SFX, Spot FX has like really a lot of fun color things in there because of this 3-wheel system that you can overdrive. You can combine it with the color wheel. Yeah, fun little light. It's very compact and really powerful. Zoom range is great. So it's been a pretty recent addition actually. I've been really liking it. I think you can do a lot of fun stuff with that. Any comments from you there, John, on the SFX?
No, it's I wasn't aware that it had so many additional functions besides just being a traditional white light subtractive color mixing system. So that's fantastic. We have about 10 minutes left, Matthias, so we should probably jump into diffuse profile and ultimately spectra color at the end here.
Yep. We can go a little longer if we need to. All right, let's look at the fuse profile. So the fuse profile is, again, an additive color mixing system. And that's part of a family. We have the fuse profile, the fuse spot, and the fuse wash FR, which stands for Fresnel. They all share the same engine. In this case, it's 305 watt RGB MA, so red, green, blue, mint, amber. As I said, it's additive. You have high color transmission if you mix versus the CMY system. However, as it's 5 colors, that may be daunting, as it is maybe with KL or the fuse pendant. You're like, wow, this is like a lot of colors to adjust if I just want to go to my favorite color that I like. So again, you're going to find the virtual colors in this one. You find a virtual CMY mode. In that mode, it acts very natural, just like it'll turn on white. When you turn it on, you have a cyan, a magenta, a yellow slider. And it will feel really natural. It works great with the color pickers in any lighting console. It doesn't have to be specially calibrated for this. And it uses all 5 colors. And that was actually a very good question in these conversion modes, that it always utilizes all of them. So here you have red. So fuse profile, as we're looking through these colors, this one has our profile name means this is a framing fixture. So you have a full curtain framing, gobos, animation wheel, iris, frost, prism. It's like a fully loaded automated lighting fixture with the added advantage of this additive color mixing system. Another advantage, by the way, of using additive color is that you have no mechanics. So there is no motors, no belts, nothing to clean. It's just one single chip in the end that does all that mixing for you. And another advantage is that it's very fast. So this is actually, you can instantly snap through colors because all it is, you turn the LEDs on and off. This would be impossible with a mechanical system because you could not move something that fast. You can get close, but you definitely can't like instantly snap between colors. That's a very big advantage of these full spectrum engines. Similar to the fuse pendant, this fixture has a color range from 2,400 Kelvin to 8,500 Kelvin. These are all calibrated color temperatures. You can recall them over DMX. There's a dedicated DMX channel for that. And as with the panel, you have, so I'm going here to 3200K, you have the same green shift control again. Depending on the mode you pick, you may have that or not in the DMX profile if you don't need that. It may not matter to you, but you can adjust minus to full plus screen. You have the same virtual color wheel. Again, interesting is also the way we structure these wheels so that they act like an actual mechanical color wheel. So you have a scroll effect that you can just call up and the fixture will cycle through these colors just as they would be on a mechanical wheel. Just you have 50 in this case that you can step through. It's actually more than 50. And again, there's a color table as part of the user manual. So you have one advantage again on this on the fuse profile is that you have a high CRI, or the TM30 value is really high as well. It's a balanced spectrum, so you do not have big peaks in there. Fixtures are calibrated to each other. You have very accurate color, temperature recall, and no mechanics. So there's a lot of advantages actually going with these additive engines, and the performance of these engines has increased so much over the last few years that this is actually a really good way to create a compact and powerful fixture like this. Yeah.
One of the things that I always got feedback on with these, Matthias, was the velocity of color change with no mechanics for color mixing.
Yes, I had that one example here. This one. So you you can step through colors without any delay. It's like instant. So if you have this on a stage, you get this really awesome color snaps going on. And that's really something you cannot replicate with a CMY system. You can get pretty close with a color wheel, but then you do not have all these choices that you have with these. So I think that's a very big advantage, the speed of that. Yeah.
We do have one question from Michael Ziegler related to why mint and not lime.
Okay. Well, that's a good question. The color is just a little bit different than, like, it doesn't match exactly to the other limes that we use. So we chose to give it a different color. So there's no expectation that the colors are actually identical. That's actually really the answer to that. Yeah, so we'll make sure you do not think, hey, that's lime, so they all have to be the same. You know, every color engine is blended a little differently depending on the application and the output you need. So in this case, mint lime is a little different than, yeah. Does that explain it well?
Great. Hopefully that answers your question, Michael.
All right, so let's look at the last one, which is probably the most exciting one, I think, in this whole lineup, because it has this really fun color engine in there, which we call Spectre Color. So Artiste Monet, which I said is also what I use here as my key light, and we use it to light up the fixtures. It's part of a family. We have the Monet, Rembrandt, and Mondrian. Something that's shared between all of them is the Spectre Color system, which is seven mechanical curtains that come in. These are CMY, CTO, red, green, and blue, or we actually call them pure red, pure blue, and pure green. And they all share a 360-degree endless framing system. We actually have a small little video we're going to show you. We'll have this ready here. And that actually has it shows you the inside of some of these features. So let's have a look at the Artiste. I'm so glad that was not me having to get colored in this video. It's a colleague Alistair in Europe. I really like the video they put together. So let's have a look at the different colors here. And you saw some how the mechanics work in there. So you have this package of 7 colors. In this case, we have cyan, magenta, and yellow. So like any traditional CMY system, we have a CTO control because you can mix from white down to CTO. In this case, it goes down to 2700 Kelvin. And then we have 3 additional colors. We have what we call a pure red, I'll fade back out to white. We have a pure green. So you got to imagine these as seamless color chips. So what you would find traditionally on a color wheel, in this case, you actually have gradual control going into this like real strong primary red and the primary green and primary blue. Also interesting is to utilize this gradually. So using the pure blue flag allows you to go through a lot of like CTB, and then it sort of tends to mix through like a purple range. So I'm gonna, this maybe, it's a bit difficult to get across probably in this webinar. There's also a difference between the mixed blue and the pure blue. So mixed blue would be the cyan and magenta wheel overlapping. On the Monet, on the Rembrandt and Mondrian, this will create a really nice Congo color. Where the pure blue gets you like a very strong medium blue. So traditionally, CMY systems often struggle with either a good primary blue or a Congo, and it's very difficult to achieve both within the same system. So with Spectra color, you actually do not have to compromise. You have the Congo that you like. You also have this very strong primary blue that you can go to. You have a very strong red that you don't have to snap into the color wheel and trying to do some timing that you don't see that. You can gradually fade into this really strong red. You can only use these partially. So in this case, this will give you light pinks. It will give you almost like teal type colors. So this fixture, which is, for instance, part of the Metropolitan Opera's package in New York, it gives them all these like opera colors, sodium vapor fixtures, the neon. Like there's all these great colors that you can achieve by utilizing a little bit of the Spectra color system. We actually even include a small instruction chapter in the user manual. And that's really, like if you ever have a chance to use this fixture and you want to try it out, I really recommend spending some time with a color mixing system. Because it's quite unique to have RGB as subtractive colors and not additive colors. They do not interfere with your console control in terms of your color picker. When you use a color picker on the console, the fixture will simply use the existing CMY. So you can stay in the CMY space for most of the time and then utilize the pure red, green, and blue colors. If you have colors that you cannot achieve with a CMY, if there's crossfades you want to do, that's where this Spectra color comes in really handy. So this would be an example of a partial red. So you can go through these light pinks, ambers, you can mix this together with some yellow. So the color possibilities are really, really infinite in this. And you can definitely achieve colors with Spectra color that are impossible to achieve with a CMY mixing system alone. And of course, with any CMY system, bringing in the CTO, so you have a CMY, RGB, and then you have this additional CTO, which is a great way to warm up colors that you mix. And in this case, the fixture also has a color wheel, because there are certain effects that you cannot achieve with a color mixing system. You want to have maybe a fast scroll of colors, just like snap, 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 that you can see when you go through. The color wheel also has some corrections on here, like a UV filter in this case. So there's an actual UV bandpass filter in here and a high CRI filter to shift the CRI into the mid-80s on the artist Monet. In this case, Rembrandt, Mondrian, that whole family all shares the same color mixing system. Yeah, John, I think we're through here with this.
Okay, I have a couple of questions that have kind of been popped up.
Yeah, that'd be great.
You have CMY and you have RGB subtractive. Why not, you use mint and lime and other additive applications. Why not a different combination?
That's a good question. We really wanted to give the designer colors that are really, really difficult to achieve. And actually, using the spectra color, you can actually get to these limes, for example, by using partial green and a little bit of blue or a little bit of cyan. But we picked these primary colors because I think that's really what you want from a fixture like this. There's like really strong red, strong blue, and strong green, which are hard to achieve. Or if you get the right color, you may not have a lot of output left because you have so much glass in front of the fixture that it may be a great color, but nobody can see it. You compete, this is a high performance fixture. They have a 950 watt engine. This is something you would place on a lot of larger arena tours, for example. So you compete with a lot of lights, video walls, other fixtures. So if you want strong green beams, the only way you could do this before was to use maybe a color chip, which you may not be able to blend into it, for example. So that was a choice we made here, to provide primaries that are hard to achieve, give you very high color output and intensity in these primaries. And it did help the overall color range so much that these colors like a lime or teal and it's like sea foam green, like these kind of things can all be achieved using the spectra color.
Fantastic.
Go ahead.
Gives us a good lead into the end here. Why don't you just give us a quick rundown of your feelings on the pros and cons of LED versus subtractive color, additive versus subtractive color mixing?
Sure. So as I mentioned throughout the webinar, additive color, big advantage is you have no mechanics. So there's long-term, there's less maintenance, there's less cleaning to do because you do not have color flags that have to be cleaned eventually. You have higher speed, on the additive colors, you can strobe colors on and off, you can strobe between colors. That's something that really would be difficult to do with a mechanical system. You have less noise because, there's motors and some mechanics in there. So if you go on a fast chase, you may start hearing some of the mixing mechanics in the fixture. You do not have that with an additive system. Another advantage is power consumption. On a fixture like a white LED, that LED will be on all the time. So if you have a 300 watt fixture, it'll put out 300 watts. Then you put your color mixing in, you may actually get only the result. You don't have that much light left necessarily. On an additive system, you only consume the power that you actually put in. So if the fixture runs all red, then that may only be 60 watts of power consumed at that moment. So that's another big advantage. Calibration between the fixtures. Mechanics have some sort of tolerances with age of the fixture. Some of the belts may get a bit loose. Maybe the maintenance over time, dirt on the fixture, all interfere with the color mixing. On an additive engine, you do not have that disadvantage. So the lack of mechanics really helps make sure the fixtures are very consistent across each other. Calibrated color temperature is something that is really you couldn't really do on a mechanical system. There's like virtual CTO, virtual colors. That's really helpful to do on an additive engine. The spectrum is more blended on these like 5-6 color engines because you can pick all the different LEDs to create a very even color spectrum, whereas a white LED engine tends to have like a really strong peak in the blues. Yeah, so that'd be probably a good summary of these different engines. The fixtures tend to be a little smaller. Color mixing package just literally takes space, where on these additive engines it's just one small disk, and you do not have to. So the fixtures tend to get smaller. They're way less. So there's a lot of advantages to that, really. But these engines, they do not exist necessarily in that high output, like where you have Monets and Mondrians and Rembrandts. So if you need punch at long distance, that may be a decade away. I don't know when maybe engines catch up to that. The majority of improvements has been in white LEDs, because they're used in cars, they're used in retail, they're used in homes. So white LED has been where a lot of the advancement and development is, and that also allows us to do a fixture like Monet that replaces like a 15 or 1700 watt discharge fixture now in a 950 watt LED. But with an additive engine, we're not really quite there. So these fixtures like Monet will stay relevant for quite some time, for sure. Maybe a decade or more until this is really caught up. It really depends on the development of LED engines. Yeah.
Fantastic. Well, thank you for that basic sum up there, Matthias. We really appreciate that. There was no more questions that came through. So.
All right, so let's wrap this up here. So we showcased 7 different examples here of color mixing systems today, from a very basic dim to warm with 2 fixtures. We have the blinder for that. Then we had an RGBW. We have the KL panel that had 6 colors, a fuse pendant with 5 colors. We have the fuse profile, RGBMA engine, the fuse SFX white with the color wheels, and we had the Monet as an example of color flags with the advantage of having a spectra color system with 7 different color flags inside. So I think it's a good representation of the different color mixing concepts that we utilize at Elation. Yeah, and that sort of wraps it up really for us today here. So I want to thank you all for attending our color mixing innovation hour, which actually took an hour and 15 now, so that took a little bit longer. But it's a lot of technology to go through and look at, and some great questions that I really appreciate. Again, I want to thank the team here at Legacy that they supported us here, specifically Tom Gorman, Tom McKnight, Tony Mahmood for the technical support, and Jake here is helping us run the camera, and Seth. So I really appreciate that they hosted us here for the day, and looking forward to seeing you again at the next Elation hour in a few weeks. Thank you so much.